In this problem, we're given a quadratic function f of x, and we are to graph it first by supplying answers to several questions. The first question is to identify the coefficients a, b, and c. So if you look at a quadratic equation in general, they can be written as ax squared plus bx plus c, meaning that the definition of a is the coefficient on the x squared. So in our case, a would be the number in front of x squared here is negative 1. So a would be negative 1. I'm going to go back here and type in a equals negative 1. The b value is defined to be the number in front of the x. So in that case, this is 4. So b is 4. The value of c is always the constant at the end. So our constant out here with no variable is negative 1. So a was negative 1, b is 4, and c is negative 1. The second thing we need to do is determine if the parabola opens up or down and state why. What happens on the graph is if a is positive, the graph looks like a U-shaped curve, so we call this opening up. If a is a negative value, then you'll get a parabola that's an upside down U. We say that it opens down. In our example, a, if you remember right, was negative 1. Since a is a negative number, it's going to open down. So here it says open up or opens down. It definitely opens down, and it's because a is negative. Another way of saying that a is negative is its value is smaller than 0, so a is less than 0. The third thing we're supposed to do is identify the vertical intercept as an ordered pair. The vertical intercept is where the graph intercepts with the vertical axis, namely the y-axis. One thing we know about the y-axis is that if you were to label any point on the y-axis, the first coordinate would be 0. So for example, if I plotted a point here, this would be 0, 2, this would be 0, 3, this would be 0, 4, etc. So since we know that the vertical intercept has an x-coordinate of 0, what you can do is go back here and plug x equals 0 into the equation and see what you'd get out. So my vertical intercept is going to be what I get out when I plug in 0. If I did that, if I replaced all the x's with 0, I'd have negative 0 squared, and then I have plus 4 times 0, and then all of this is going to yield 0 so far. And then finally, after that, we have a subtract 1. So basically, the only thing that survives in general is the value of c. In this case, what's c? 0 squared is 0. The opposite of 0 is still a 0. 4 times 0 is 0. So all of this yields 0. And then you have a subtract 1 down here. So by plugging in 0, you get negative 1, which is exactly what our value of c was to begin with. So in general, your vertical intercept is always going to be 0, c. In our case, c was negative 1. So our vertical intercept is in point notation, left parenthesis 0, negative 1, right parenthesis. So I'm going to go back here and do just that. Type in left parenthesis, shift 9, 0, c was negative 1, right parenthesis, so shift 0 on the keyboard. And that's the answer to question 3. Question 4 says to graph the function on the calculator. Question 5 is to basically copy the graph from the calculator onto this Cartesian coordinate system here. And finally, place a point on the graph at the vertical intercept, which we already know is 0, negative 1. So because they want us to plot the highest or lowest point, I'm going to do that quickly by hand because they made these problems at least arithmetically simple. To find the vertex, the highest or the lowest point, you use the formula negative b over 2a. If you don't know how to do this, go back one problem on Math AS, and I have a video showing this. But the x-coordinate of the vertex, so my vertex is going to be a point. And the first coordinate, the x value, can be found by taking the opposite of b, and dividing by 2 times a. So our b was 4, but we're to change the sign to negative 4, and then divide by 2 times a. But if you remember our case, a was this coefficient here, negative 1. So we have negative divided by negative is a positive. 4 divided by 2 is 2. So my x-coordinate of the vertex is 2. And again, they made this sort of arithmetically simple. So I'm going to really quickly just replace all the x's with 2. So if you know the x value of a point, you can always find its y-coordinate by simply plugging it into the original equation. So if I plug 2 in, you'd have negative 2 squared. And because they made this one simple, I'm going to do it by hand. So replacing all the x's with 2, that would look like this. Order of operations state that exponents come before multiplication. So in your exponent rules PEMDAS, remember that since there's no parentheses here, I've got a choice between doing the exponentiation here, or I think of it as multiplication by -1. So it turns out exponents come first. So I'm going to take 2 and square it, that gives me 4. Then it's as if I'm doing multiplication by -1. You can think of -2 squared as literally being -1 times 2 squared. So 2 squared is 4. 4 times -1 is -4. I have 4 times 2 is 8. And then I have to subtract 1 at the end. -4 and 8 make 4, and then I have to subtract 1, so I get 3. So our vertex, unless I did some arithmetic error, should be 2, 3. Let's check that. Let's see, I'm going to go to my graphing calculator here, and I'm going to hit y equals. To type my equation in, it's -x squared, so use the negative key, not the subtract key. You're not subtracting x squared from something. So it's the opposite of x. There's the x key squared. Here's the squared key. Plus 4x, and then subtract 1. Now this should show up on a standard window, so I'm not going to have to fill out the window. To get a standard window, hit zoom 6, and not only will it adjust your window settings, but it'll actually graph the equation for you. So we should be getting a parabola that opens down, as promised. We also found that the vertical intercept, if you remember, was 0, -1. That looks pretty plausible there. Now, we found by hand that the vertex was 2, 3. In fact, I'm actually just going to type in 2. If you hit the trace key in the graphing calculator, you get some x and y coordinates down here. And if you just type in 2, enter, it'll actually show you the point on the graph whose x value is 2. In fact, it says if you plug in 2, you get out 3. And it looks pretty plausible that that would be the highest point on the graph. Looks can be deceiving, but at least it looks plausible. So now it gives me an idea how to graph this. We're going to plot the point 2, 3 as the highest point, and the directions, if you remember, after plotting the highest or lowest point, plot one other point, which since we already know the vertical intercept, I might as well use that in our plot. So make sure you're on not the plot feature, but the draw quadratic feature. Our vertex was 2, y value of 3. I'm going to click and hold the mouse button down. You can see you can graph all kinds of parabolas. Our parabola was supposed to open down, and if I remember right, its vertical intercept was 0, -1. Now you don't have to plot this point, you could plot any other point, but since that's the other point I've found so far, I'm going to choose that one. Now be careful, the directions say a little more. It says, finally, place a point on the graph at the vertical intercept, not the vertex, the vertical intercept. So that's this guy right here, 0, -1. To plot a point, you use this icon here. You click on it and do just that. Click at the point 0, -1. And that's how you do the problem.